Okay, we're going to start getting into more trigonometry in this unit. And in order to deal with trigonometry, we need to learn a little bit more about angles and what an angle means. And then we're also going to have to learn about radians and how we convert back and forth from radians to degrees, degrees to radians. So a lot of measurements in math are made using radians, and I'm guessing that is fairly new for you guys in this class. But to begin with, let's start with angles and refresh our memory of what an angle is and how we're going to define angles in pre-calculus. All right. An angle is generated by the rotation of two rays that share a fixed endpoint. That fixed endpoint you might remember as being a vertex. So here's a ray, and remember a ray extends forever in only one direction. And if I have an angle and I have two rays, here's its vertex, and here's its two rays of shade. All right, so what we call how we measure an angle is we call how much did it rotate, how much did it go, how much did it rotate? Say it's starting at this angle to this angle. How much did it rotate? Say that's 30 degrees. I don't know. And we measure that using a protractor or something like that. And a lot of times it's given for us. But that's how we measure. That's what an angle. That's what angle is. It's a 30-degree rotation up. Okay. And what we have here in this, since I've already drawn this terminal side or this angle here, what I have here is what's called a terminal side and initial side. An initial side is where our angles start. So this is the initial side. And our terminal side is where it starts. So our initial side is starting where our rotation begins, and our terminal side is where it ends. So this is a terminal side, okay? So in a lot of cases that we deal with, we're going to have angles that have an initial side going down the x-axis in the positive direction, and it's starting at the origin. All right, and we're measuring our degree as it moves counterclockwise. All right, so something like that. Here would be my terminal side. Over here, this is my terminal side. This would be my initial side, and this is my degree measure, whatever that ends up being. All right. As we're moving counterclockwise, that's positive angle degrees. So our positive angle degrees move counterclockwise. All right, so say this is a measure of 120 degrees. All right, this is a positive 120-degree angle. If we continue going, like say let me clear this, and say we had an angle that had an initial side here, and maybe it came down here as its terminal side, it would have a positive angle measure of almost 360 degrees, because 360 degrees is what's in a circle. Say it's 330 degrees. Say we have an angle of 330 degrees. That's its positive angle measure. Its negative angle measure would be if we go the other way. If we take our initial side and we go clockwise. So this would have a angle measure of 30 degrees. Sorry, my pen was freaking out there for a bit. But this would have an angle measure of 30 degrees going in the negative direction like that. So when we're going, so sorry, my bad. It'd be negative 30 degrees would be this guy's angle going in that direction. The negative sign indicates what direction you're going, either clockwise or counterclockwise, all right? So anything that's positive is going to be a counterclockwise movement in angle, okay? Standard position I kind of talked about already. Standard position is where the angle is going to start at the origin, and it's going to have a initial side along the positive x-axis. All right, that's standard position. And then the last thing to talk about, or last two things to talk about, is the quadrants and a quadrangle angle. All right, so the quadrants is, if you remember, we've had this, I don't know how many times, that's quadrant one. And again, we go counterclockwise. This is quadrant two, this is quadrant three, and this is quadrant four, going counterclockwise. All right, and a quadrantal angle, sorry, I have problem saying that, is an angle that ends up landing on one of these vertexes. So this is an angle right here, and we all know that this is a 90-degree angle. All right, so that's an angle. Also, it could be an angle that goes straight out here, which would be a 180-degree angle. And then if it was an angle, let me clear it. And say we had a angle like this, that would be 270-degree angle going this direction, or a negative 90-degree angle going the other direction. All angles can be written with a positive measure and a negative measure, all being subtracted from 360. So how I'm getting that is 270 minus 360, because 270 is this positive angle measure. Negative angle measure would be that, so negative 90. And that just means we're going the other direction. Okay, so we've talked about everything we have here. Moving on. What a degree is, the official definition of a degree is it's an angle measure of 1 degree if it results from 1/360th of a complete revolution in the positive direction. So when we talk about a revolution, we're talking about one circle. So if we're talking about a circle, if it goes 1/360th of us around that circle, it's a degree. So you know that there's 360 degrees. So each degree, the circle's made up of 360 degrees. Okay. Each degree has 60 minutes in it, and in each minute has 60 seconds. So it's just another way for us to write, for us to write degree measures in minutes and seconds. When it only has 1 tick by it, that means minutes, and when it has 2 ticks by it, it means seconds. So this one, an example 1 says change 29 degrees, 45 minutes, and 26 seconds to a degree number of degrees to the nearest thousandth. So what we're going to do is we're going to convert this so it's a decimal instead of in minutes and seconds. So what I'm going to do is, we know that we have 29 degrees, so that's our whole number, and it's going to be point something. Well, we got to figure out that something is, so we'll add to it 45 degrees, and then we said there's 60. Not 60. There's 60 minutes in a degree. So there's 60 minutes in a degree, so we're going to have 45 out of 60 minutes, so it's going to be some decimal. And then also we have 26 seconds. I can't understand why my pen's going crazy. Here we go. Plus 26 seconds, and there's 60 seconds in a minute, which means there's 3,600 seconds in a degree. Okay, and so in order to convert that, all we're going to do is we're going to multiply that out. So it'd be 40 divided by 60, or 45 divided by 60, which would be 0.75. And then 26 divided by 3,600, which is 0.0072. And all we got to do is add those together now. So we'll have 29.7572, and they wanted the nearest thousandths. The thousandths place, tenths, hundredths, thousandths is 7. So really we could just write this as 29.757 degrees. All right, so that's how we change it from minutes and seconds into degrees. Okay, and moving on, we're going to skip that example because I think you guys got that figured out. If you want to do that in your notes, that is completely fine with me. We're going to talk about radians now. All right, and a radian is a different measure for a circle, and everything that's dealt with radians comes from the unit, so what's called a unit circle. A unit circle is called that because it has a radius of 1 unit. All the way around, it has a radius from one unit. So no matter what, if I start in the center and go anywhere to this circle, that distance is always 1. So from here to here, obviously, is 1. It marks it as 1. From here, anywhere on this circle is 1. So that's an example of the unit circle. Okay, so everything we do with radians comes from the unit circle. And here's the definition. Radians based on the unit circle, we said that. It has a radius of 1. The distance from the origin to any point on the circle is 1. That's what I just showed you. The unit circle is symmetric with respect to the x-axis, the y-axis, and the origin. The equation of the unit circle is x squared plus y squared equals 1. If you remember your formula for a circle, this means that this is the square root of this is its radius. The square root of 1 is 1. All right. It says a radian is the arc length of the angle on the unit circle. So a radian is more of the distance around that circle. So when we talked about the degrees of an angle, so say we have an angle like this. All right. The degrees measure the rotation right here. And what a radian does, and here's the difference, what a radian does is it measures the distance we traveled around that circle. So the distance we traveled around that circle is a radian. All right. So 360 degrees is going to be the same as has a distance of 2 pi. All right. And so what we're going to end up having when we have radian measure is going to be a fraction of the circumference of a circle. So the circumference of a circle is 2 pi r, and we know the radius is 1. So 360 degrees has the equivalent radian of 2 pi because it's a fraction of, okay, so if we, the distance around this entire unit circle, if my pen would be working, there we go, if over this entire unit circle is 2 times pi times 1, that's the radius is 1. So the distance around that entire thing, all right, is 2 pi. So when we're talking about a fraction of that, and we'll get to how to convert that in a little bit, but we're talking about the distance of that angle, the distance from here to here, the distance of that arc. That's the difference between a radian and a degree. So therefore, half of a circle. So if the entire thing around is 2 pi, all right, so half of the circle, would be right here, all right? So half the circle would be 180 degrees, so the distance around the half of that is pi, and then obviously every 90 degrees then has to be a fourth of the circle, which would be 1/2. All right, so distance, or pi over 2, sorry. Pi over 2 would be the distance there, okay? So 1 radian equals 180 degrees divided by pi, and 1 degree equals pi divided by 180. That's our conversion, all right? So that's our conversion. So if we want to change 30 degrees to radian measure in terms of pi, you're going to have to remember back to your pre-algebra days where you could cancel out units, where you learned how to cancel out units. So in this case, 30 degrees to a radian measure, we want degrees to cancel out. This is how I remember it. 30 degrees to a radian measure, we want degrees to cancel out. So this is 180 degrees. When we multiply these two things, we want the degrees to cancel out. So this has to be pi all over 180 degrees. All right, so we want the degrees to cancel out, so we're left over as radian measures. And then obviously we can cancel this out, and the zeros cancel out, and then we can cancel out the 3, and this becomes a 1, and this becomes a 6. So 30 degrees is just pi over 6 radians, and that's how we converted it. Remember, we just used this conversion right here because we wanted the degrees to cancel out to become a radian. In the same sense, if we're changing radians to degrees, we got to remember our conversion. So 3 pi all over 4. And we want the pi's to cancel out. So they got to be opposite. So we're going to want 180 all over pi. All right. And if we have that, pi's cancel out. And again, we can look diagonal. All right. And 4 goes into 180 times. It goes in there 45 times. And we know that 3 times 45 then is 135 degrees. Why percent? Well, I don't know why I wrote percent. 135 degrees. Sorry, my pen's been throwing me off. That's been going crazy. Okay, so 3 pi over 4 is the same thing as 135 degrees. We'll do one more example of that because we still have time to talk. One more example of that. Okay, so we know our conversions. We want to change 45 degrees into radian measure. So we want degrees to cancel out. So degrees have to be on bottom. And this is over 1, right? 45 over 1 degrees. Degrees cancel out. And then we'll look diagonal to cancel out. And we know that 45 goes into 180. This would be 4 times, and this would be 1. So we know that 45 degrees would be pi over 4 as a radian measure. And then again, now we're going to change the next one. We're going to change from radians to degrees. So 7 pi over 8. And again, we want radians to cancel. This time we want the pi's to cancel out because degrees doesn't have a pi measure in it. So we're going to cancel out. So we need the pi on the bottom and 180 on top. And the pi's cancel out. And then we look diagonal with 180 and 8. 4 can go into both of them 45 times. that should be 2, my bad, and 45 times. That's all we can cancel out, so 7 times 45 is 315 divided by 2. So when we divide that by 2, that is the same thing as 157.5 degrees when we convert it. So 7 pi over 8 is the same thing as 157.5 degrees. So I hope this helps. I think that's all I have for you in this section. And remind me in class if I do not pass this out to you. I want to pass the unit circle out to you. We'll use this throughout this section. That will be very helpful to you throughout this class. So I hope that helps. We'll see you in class.